statistic and inferential statistic. So we start by defining what they are: descriptive statistic and inferential statistic. The descriptive statistic gives a summary of the set of the data. So which means, so you have something like drawing charts, calculating mean, percentile, tables, and graphs. So you are just giving like the summary of that data. You're describing that thing. So the graphs maybe can tell you, a question can ask you like, what is the percentage of men in this population, percentage of women in this population? And then you draw the graphs and see which one is higher and which one is the lowest, the largest, something like that. So it doesn't really give more about the data. And inferential statistic is when you have to make a study, you decide to do a study. And then this study, of course, it will not be done on the whole population. Most of the time, it depends on the done on the sample, specific group in the population, and then you make some assumption on the result that you will have got if you did the study on a population. That become inferential statistics based on generalization. Most of the time they are not accurate, they're just assumption. And then the next one, we look at the measures of centers. And measures of centers is a value at the center or the middle of the data. For example, mean, median, mode, and mid-range. The mean of a data, or simple mean, is found by adding the values and dividing the total by number of the values. So this is the same thing too. It can be sample mean or population mean, either of the two. If you decide to do a study on a population, and then it become like a population mean, so you have to add up all the observation that you made and then the number of your observation, then that gives you the population mean. For sample mean, if you decide maybe you're making a study on students in Canada universities, and then you decide on Toronto University, so that and then you do your observation, calculate it by dividing the total of your observation by the number, then that becomes sample mean. Next, go show you how the formulas. This is how the formulas look. They give you the same answer, but they have different letters or how they look. So with the population mean, you use capital N, and the sample mean, you use small n, which means it's a set of the population that you're doing. It's not the whole thing. And then the n one is the whole thing. So this thing is not more important now, but later on in our next videos, you will see how is it important for us to know which one is the sample mean and which one is the population mean when you had to go and calculate other stuff. So let's see the example. So there are the properties of the mean. Most of them, variation of the sample mean is small compared to the other measures of centers. And then the other thing is they always like use every other data information, and then they're also affected by the extreme values. I mean, if you're doing a study on a population, it would be like hectic for you to add all the observation and then you add them up. it can create like inaccuracy. Okay, so the example of the sample mean, it state this thing is low, but the annual incomes of a sample of the middle management employees at something like that Westinghouse are 62,900 and 69,100, 58,376,800. So when you have to calculate, these are all your observations. So these are observations of the incomes, the annual income that an employee's hand when they are a middle managers in the Westinghouse. So it range from 658 to 6,000. So when you have to calculate the mean, what will be like the mean, which means the middle number? If anyone want to decide to come and work in this company, they will just always want to know what the mean, the minimum, what the means on average, how much do they earn? So here, so you have to add this number plus this plus this plus this, and then you count 1, 2, 3, 4. So you have 4 observations. So after you add up all this, you divide it by 4. So let's see. So because it's a sample mean, you will use this formula. So sometime maybe even you're working out in your exam sheet and you want to not on your exam paper, and then you want to show that you know the formula. So sometimes you write the right formula, sample mean. So you pick that, put it in, because maybe your professor might think that you don't know what you're doing if you're asked to calculate sample mean and then you put the population mean. So this is sample mean. So we'll take this formula and then now we are adding up. So we add 62,900 plus 69,100 and then 58, 76, and then you divide it by 4. The answer that you get is 66,775. That is our mean, our sample mean. So if you were told that those the information that you have, all the observations were like population, and then you add them up, divide it by 4, and then it will still give you the same answer. On this section, you ask is the mean you have computed above a statistic or a parameter. So as we did before in our previous video, that we have statistic and the parameter. So when it's statistic is when you are dealing with the sample mean and with the sample. But when it's parameter is when you're dealing with the population. So when your study is based or covering the whole population, and then it'll become like parameter. So in this case, we have a statistic because it is based on the sample values. And then the next one is your best estimate of the population mean. What is your best estimate of the population mean? So the best estimate of the population mean is 66,775. What it means is that for you to do in inferential statistic, all the results that we get later on, they are based on the sample. So when we get this value of the sample, it becomes our estimate of the mean and the population. So that's why we do the sample study. So we do the sample so we can guess what would be the results when we had studied the population. So that is it. So we have another example. When you have to calculate the population mean, it's the same process. So you just have to add up and then divide. The only problem that you use the population means formula. So which means it's the same thing, it's only like the appearance. So here we have all the students in advanced computer science 411 are considered. The population, their score grades, their course grades are 92, 96, 61, 86, 79, and 84. So here population. So here our study was based on student, but in this case, all student. Anything that say all, it may like you study the whole population of that, all the student in that school. So it become like the population. Maybe if you had decided, maybe I'm doing a study on a student with disabilities, or maybe student with children, and then it becomes example, you're making a selection on that, on the whole population. So we are dealing with population in this case. So in that case, we have to select population means formula here, the one that start with this thing that look like U, and then the different, you use the end, this capital N, the number of items in the population, that is the population. So here we do the same thing like we did in when we were calculating sample mean. Compute the mean, the course grades. So here you add up 92, 96, 61, 86, 79, 84, and then you divide by the number of the population. Here is 6, so you get 83. This class look like people are very smart, so you get 83 as your population mean. So here is the mean you computed in this case. Above, statistic or a parameter. So as obvious, it is parameter because your study was based on all students of that school. We mean it's a population. You're calculating the whole population of that student, of those students, of those students, and you're taking their course grade. You didn't make any selection among the students, so become a parameter. A parameter is our answer because it was calculated based on the population values computed. So next one is the median. When I was in primary school, I used to inch median, the middle part, the midpoint of the values after they have been arranged from the smallest to the largest. So this is easy. Some people, they get it wrong when you just rush in and then you try to get your mean without arranging them. You have to arrange them. This need organization. So you have to arrange them. You can decide whether you go from the smallest to the largest or from the largest to the smallest. And be careful, use your eyes properly so you can not confuse the numbers and not put them in a proper order. So once you get that, and then you get to calculate your mean. Example of the median. Median. The quality control department of this company, Peanuts company, Peanuts, is responsible for checking the mass of 500 jar of peanut butter. The masses of a sample of nine jars produced last hours are, you have one that weigh 504, 505, 500, 490, 495, 496, 498, 500, 501, 501. What is the median mass? So this is like the primary school's things. So you arrange them from the largest to the smallest, or from the smallest to the largest. This one is not sorted, so it's still like there are 495 there and 496 there. So let's do it. What is the median? So let's see how we could do this. So we arrange them. This is still a row, so now sort it. You have 490, 495, 496 all arranged out. So the median will be 500. How you get this? In how I use it, I get a pen and then cross that and cross that. Cross this and cross that. Cross that and cross that. Number 3, cross that and cross that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So all these numbers, the total is 9, which means they are odd numbers. Which means when you cancel one by one from both sides, you will remain with one number in the middle. And in this case, it's 500. So you have 4 on this side, you have 4 on this side, and then you have other 4 on this side, and then you get 500, which is your median. What about if you have like an even number, the one that you will remain with 2 numbers in the middle? This is the alternative example, or not alternative actually, but another example, another way of doing this. So you have this row numbers is not sorted, and then you sort it out. When you sort it out, you have like two 500 remaining in the middle. So you cancel this one with that, cancel that one with that, cancel, like this is the one with the even number. So when you cancel all the numbers from both sides, and then you will remain with 2 numbers in the middle. So what you do, you add them up and divide it by 2. Then you get your median, which is 502. So the mode, the mode is the most common number. It's the value of observation that appeared mostly or frequently in, for example, when we have these numbers, maybe it's coming 10, 10, 10, 10, 10, or 11, 11, 11, 3 times more than the other observation, and then it will become a mode. So the number of workers stoppages in the automobile industry for selected month are 6, 0, 10, 14, 8, and 10. So in this case, what number is, or which number is appearing like more than 1 time or more than 2 times? So here we have 10 and 10. So 10 become our mode. So our next video will be on the dispersion. Dispersion or dispersion? Dispersion of the data. So we'll learn more about that when that time comes. And I hope you enjoy my video, and thank you for watching, and see you next time. Thank you.